Alright people, let us make our first box and whisker graph, and let's have a little look at what that graph is telling us. So I'm going to try and import some of that data that I've got from census at schools. So I'm going to go here, I'm going to open up that file that I've got. Now I've got quite a few different ones here, but I've already practiced with this one, so I'm going to choose that one. So the things I was looking at was the years of these students, year 7s and year 12s, and I looked at the genders, and then I looked at heights, and I looked at bag weights, and I looked at reactions times. So I'm now going to have a quick look. I've chosen a few different things because that's going to give me some options. So I know I'm going to do a dot plot. I know I need, first of all, up here, I need to choose a numerical number. So let's go with our bag weight. That sounds kind of interesting. And we'll go with boys and girls. So there are my dots. But I don't just want dots. I want box and whiskers. So I'm going to use this one here. Now this particular box and whisker ignores what we call outliers. So we take the distance of our box and we go 1.5 times, and anything that's outside there is ignored as too big, too weird, too strange. Okay, so the last thing I need to put on there is what I'm going to call an informal confidence interval, these little blue bars. Okay, so looking at males and females and looking at their bag weights, we have blue bars that overlap. The blue bars is my best guess of where the average would be, the median would be, and these blue bars are overlapping, so I can only say that there's actually no real difference between males and females because the informal confidence interval, the blue bars, are overlapping each other. So I'm going to have a play with my numbers to see if I can find one where the blue bars don't overlap each other. So let's change gender to year. So now we've got year 7s versus year 12s. Okay, I've got a much bigger blue bar because I haven't got many year 12s in my sample. Year 7s tend to do the sample, the census at school, much more often than year 12s do, so therefore we get not as many year 12s in our random sample. Alright, so that one's, again, overlapping bars, not that interesting. So let's try another variable instead. Let's try reaction time. Okay, now we've got something really weird here. It's really, really squished up so much that we can't even see our box and our whiskers. And it's because of this person. This person here who was distracted or got lost or didn't know what they were doing and took 71 seconds to react to this particular thing. So they were probably mucking around. So if I wanted to go with reaction time and see what that was, this is person 9, 71.92. So if I go to my numbers and I look for person 9, no, that can't be what that means. Oh, there, no, sorry, ninth one down. Here they are, 71.912. So if I really, really wanted to use this information, I should probably get rid of that person. I would highlight them and delete them so that when I import those numbers, then I don't have that really, really odd person. So let's do that. I'm going to save that. I'll go back to NZQA. I'll pick up my information again. So that very, very same file. There it is at the top now because I've modified it. So let's do reaction time versus year. Let's see if that's made any difference. No, that person's still there for some reason. Can I remove them from here? What happens if I just remove them from here? Okay, nothing. So this is quite interesting. I must have a little play with that. Alright, So even though I removed this person, okay. Oh, okay. So now there we go. Removing that person has in fact given me a much different graph. So it's still very, very squished. It's still got all these weird people out here, and that information's hiding away. So I'm going to try another thing here. Let's try an old buddy goodie. Let's try height. All right, so there we go. Year 12s versus year 7s. Even though there's not many year 12s, we still have a big old gap in there. The blue bar finishes here, and this one does not overlap with that one. So even with this, we can tell that year 12s on average are taller than year 7s because my informal confidence intervals do not overlap. Right, so let me just finish off with that last one there, maybe gender. Okay, if I do that, I go back to overlapping. I in fact get females being slightly taller than males, and that might be early onset puberty for females in year 7 having that effect. So when I'm going to choose, if I had to choose the most interesting one there, where the bars do not overlap. Okay, that wasn't it. It was year versus, oh no, stay with height versus year. Height. Okay. Right, something weird has happened there. Oh, we have to do it this way around, don't we? Otherwise it just doesn't work. Variable first and the category second. So the category is what year they're in, and the variable is how high they are. Okay, so the blue bars do not overlap. Gives me lots to talk about, especially since my year 12s is such a small group, my year 7s is such a big group. There is potentially lots to discuss. So I'm going to choose this group, these things here to investigate: height versus year. Okay, well, that's a rather long-winded way of discussing all these things, but the important things are choose something interesting, play with the few of the numbers until you get one choice that you like, and then that's the one you're going to investigate. That's all for now. I'll catch you next time.